Hello everyone. Today we're going to talk about action potential. Action potential is an electric pulse that goes through a nerve cell and upon arrival of a stimuli. So stimuli kind of comes here at the dendrite area. Dendrite area is those nerve fibers that receive a stimuli and that it generates that electric pulse throughout this axon region, and that electric pulse travel in this direction. So electron pulse like this. So that's the action potential goes through the cell membrane and reaches synaptic knobs. And at the synaptic knobs, the chemicals are released on the muscles, and muscles contract. So this is the whole process of action potential. We will talk about on the graph right here how that occurs and which channels are open and when they are closed. So let's see, a stimuli comes in right here at negative 70 millivolt. So this millivolt, 70 millivolt is a resting membrane potential when nothing happens. So at that point, when ions start coming into the cell, sodium ion coming into the cell, it start to decrease its negative value. So the charge start going little bit on the positive side, and when it reaches a threshold value, which is this line right here, all those voltage gated sodium channels, which is right here at this point, they get opened. So when they got opened, and the sodium start flowing into the cell from its gradient. So there's high level of sodium outside the cell membrane. So I show you right here. So sodium is right here, and there's a lot of negative charge right here. So when this sodium voltage gated channel opens up, all the sodium start flowing in. So positive charge start coming in, and this process continues until it goes to the roughly about positive value of 35 millivolt. Okay, and this process called depolarization right here. So the curves kind of going up from here to there. This is called depolarization, and and during this sodium coming in, let me show you the next section also start doing is checking of its threshold value, because the sodium is started to come in, and the next section also started to um, pass the action potential from the previous section right here. Okay, so at this point the voltage gated sodium channels are inactivated. Okay, so no more sodiums coming in. Now it's time for the repolarization. Means there's gonna be more negative charge coming into the cell membrane. So the sodium channel closed. Okay, and at the same time the potassium that is inside the cell membrane, which has a positive charge, to start to flow out. So voltage gated potassium channel opens, and potassium started to go out, and the positive charge of potassium going started going out, and the negative charge started building up inside the cell membrane. So up to here it was all negative, then positive, then it start replacing this repolarization in this section only. Okay, so now uh, negative charge building up again at the same point where the depolarization occurred, and up to this point um, it goes beyond a little bit 70 microvolt, but then it comes back to its resting potential. So this area is covered. Now similar process occurred onto the next section of the nerve, next section of the axon, next section of the axon, and this is how the action potential passes from one end of the cell membrane to the another, and finally reaches synaptic knobs and release the chemicals on the muscles. So hopefully you enjoy that video. In summary, there's a depolarization occurs, and then repolarization occur, and the membrane comes back to resting potential. first sodium uh, channel activated right here, then it got deactivated, then potassium channel opens and started doing the repolarization. All right, till the next video, have a good day.